Okay, this video is for Math 116, and this one is on section 1.8, inverse function. So the idea of an inverse function is that it's going to undo the process that a function does. So let's say if, just in general, if f of 3 is equal to 7, then if we take our inverse function, that's not an inverse function. The inverse function is typically written f negative 1 of the y value will give you back the x value. Okay, so let's talk about this with a really simple example, and then I'll get into what's in the textbook in a sec, which is a little bit more complicated. So let's say we've got our function f of x is, let's use different numbers than the ones we were using in the previous example, 5x minus 1. Okay, so the process for finding a function inverse is to get the x by itself, so there's the x by itself, and then swap the x and y's. So this will be y equals x plus 1 over 5. This is our inverse function. Okay? So here's the original function f. Here's the inverse function f inverse. I don't want to say f to the negative 1 because it's not a power. It's not an exponent. It's an inverse function. Okay? So let's see. Is this true? F of 1 equals 5 times 1 minus 1. That should give us 4. Okay. What about f inverse of 4? 4 plus 1 over 5. 5 over 5 is 1. So yeah, f of 1 is 4. F inverse of 4 is equal to 1. And it shouldn't just happen for one ordered pair. It should happen for all ordered pairs in the function. Okay? So I'll go over this process with a bunch of examples in a minute, but the general process is to get the x by itself and then swap the x and y's, or you can swap the x and y's first and then get the y by itself. It's essentially the same process. All right, so why are we doing that? What is exactly going on when we do that, and why do we swap the x's and y's? That's something I think people often find confusing. Okay, so let's talk about why we do that. And I saw a really clear explanation of this when I was doing this with applications. So here's an application function. H of t is 100 minus 16t squared. So this is a height function. As a function of time. If you drop something from 100 feet off the ground, the distance it falls after t seconds is going to be minus 16t squared. So its height as you drop it from 100 feet will be given by that function right there. Okay, so what if we wanted to find the inverse function? All right. Well, let's just replace this with a regular h. And now let's get the t by itself. I'm going to move this over here and then move the h over here. So I'm going to add 16t squared to both sides, and then I'm going to subtract h on both sides. And that's how I'm going to get here. And then I'll divide on both sides by 16. T squared. And then we'll square root both sides. So our inverse function here is that t is equal to 100 minus h, or square root of 100 minus h divided by 16. And if we want to use that function notation, I'll use a capital T on h, is this square root 100 minus h over 16. Okay, so here's our original function, 100 minus 16t squared. Here's our inverse function, square root 100 minus h divided by 16. And in the textbook, I show you the graphs for these. Let's see, this one here. You've got the t is the independent variable, and then h of t is the dependent variable, and it looks something like this, right? It's 100 feet off the ground at t equals 0, hits the ground somewhere between 2 and 3 seconds. Okay. Now if we do the inverse function, now the h is the independent variable, and the t is the dependent variable, and that one is going to look something like this. Okay, and that's kind of a this graph itself, this function itself, is not all that helpful. I think at least in particular the graph, because it's kind of backwards, right? When it's 25 feet off the ground, that happens in 2 seconds. When it's 100 feet off the ground, that happens at 0 seconds. It doesn't really give you a lot of insight into the falling object. But what I find that it does give you insight into is what happens in an inverse function. Okay, so we just swapped the axes. The h is the independent variable, so we put it on the x-axis. Here the t was the independent variable, so we put that on the x-axis. Now, if we started out f of x is 100 minus 16x squared, and then we wanted an inverse function for that, we'll start out with y equals 100 minus 16x squared. Now let's get the x by itself. Move the 16x squared over here, move the y over here, divide on both sides by 16, and then we'll square root what's left. And in the end, we get x equals square root 100 minus y over 16. But now, and I talk about this in the textbook, the issue is that when we graph with x's and y's, the x is always the independent variable. The y is always the dependent variable. So to satisfy that condition, we have to swap these around. That's what's going on when you find the inverse function. Okay? It's just that what we're doing is we're actually swapping the variables. And you can see that very clearly in this application, but it doesn't work as well when we're sticking with the x's and the y's, because by convention, the x is always the independent variable. Okay? All right, so that's what's going on. The process is get the x by itself, swap the x and y's, or swap the x and y's and get the y by itself. All right, I'll do some problems one way and I'll do some problems the other way. It really doesn't make any difference how you go about doing it. Okay, let's look at some problems in the textbook here. Okay, let's see here. Well, let's start with problem 4. So, f of x equals 1 minus 3x. So replace that with a y. I mean, you can keep it as f of x, it's just more writing for you. All right, now let's get the x by itself. So 3x equals 1 minus y. Divide on both sides by 3. And now swap the x and y's, and that is our inverse function. There it is. Okay. All right, what else? Let's look at problem 6. We've got f of x is equal to x cubed plus 1. So we'll write this y equals x cubed plus 1. I think for this one, I'll swap the x and y first. Okay, x equals y cubed plus 1. Now we get the y by itself. X minus 1 is y cubed. Take a cube root. Y is the cube root of x minus 1, and that is our inverse function. Okay? All right, let's see what else. let's look at number 10. Number 10, f of x equals negative 3 over x. So let's use x and y. So now let's get the x by itself. To do that, we got to get the x out from the denominator. So we have to multiply on both sides by x. And then divide on both sides by y. And so y is negative 3 over x. Turns out this function is its own inverse. And that does happen from time to time. Okay? If you remember the graphs that I drew for those example inverses, right? You could see that they kept the same shape. What happens because of that thing where we swap the x's and y's, an inverse function will be the original function reflected over the line y equals x. So if you get something like this, negative 3 over x, that is going to look something like this. Okay? And if you reflect this over the line y equals x, see how these are symmetrical? Any function that's symmetrical about the line y equals x will be its own inverse. So that's just something about a function being its own inverse, and how can you tell? All right, let's see here. So that was problem 10. Let's go at problem 12. So in this one, f of x is 4 over x plus 2. Okay, so let's see. Let's replace that with a y. And so on this one, I'll get the x by itself and then swap x and y. To get this x by itself, you've got to get it out from the denominator. And the only real way to do that is to multiply on both sides by x plus 2. Then those two will cancel. Then you'll have 4 equals x plus 2 times y. Then we'll divide on both sides by y. And those cancel out. And then subtract 2 on both sides. So here x is 4 over y minus 2. And the last thing we should do is swap the x and y's. There is our inverse function. Okay? A lot of times people have difficulties clearing out these denominators. It's part of the reason why I've got these problems in this section. Something that is really important to get used to if you plan to take more mathematics. Okay, let's see here. What else? Problem 14. F of x is 4 over 2 minus x. All right. So let's write this as y equals 4 over 2 minus x. On this one, I'll swap the x and y first. And now I've got to get the y by itself. Whichever one you prefer is the one that you should do. Okay? I typically try to show students more than one method for solving a problem. And these are not even really two different methods. It's just the order that you do things in is slightly different. Okay, so to clear out this denominator, multiply on both sides by 2 minus y. And now, oops, I'm getting ahead of myself. That'll just be 4. And since I've swapped the x and the y's already, I'm trying to get the y by itself. I mean, that's something that can be confusing in these problems. 2 minus y equals 4 over x. Okay, let's see here. I'm going to add y to this side and subtract 4 over x on both sides. So this will be y equals 2 minus 4 over x, and that is our inverse function. Okay. else we've got here. Let's look at problem 16. Problem 16, f of x is negative 2x over x minus 1, so we'll call that y. Alright, so again, we want to get rid of this denominator, so let's multiply on both sides by x minus 1. Now I didn't swap the x's and y's, so we're still trying to get the x's, we're still trying to get x by itself, okay? Alright. Now, in the last couple problems at this point, I've divided on both sides by this variable right here. But if I do that, that's not really going to be helpful. That's not going to help me get this x and this x together. Okay? So let's back up, go back to where we were. What will help me get these two x's together is to distribute this y into the parentheses so that we get xy minus y is negative 2x. Alright, now I'm going to get these x's together and I'm going to move the y to the other side. So then I get xy plus 2x equals y. Now we're getting close. We're very close to solving this. The key to getting the x by itself here is to factor it out. Now you can divide on both sides by y plus 2. X is y over y plus 2. Last thing we do is swap the x and y. Y equals x over x plus 2. That is our inverse function. Okay, so that's the first of those somewhat tricky ones. Okay, the rest of these are relatively straightforward, but starting with 16, they get pretty tricky. So let's see here. Problem 18. F of x negative 3x plus 1 over x. All right, so let's see here. Write this as y equals, and let's clear out that denominator. That's usually the first thing to do when you've got something like this and you need to isolate that variable, is to clear out the denominator so these cancel out. Xy equals, now this is a little bit tricky too. You've got this negative sign hanging around. Well, it's not just going to affect the 3x. It's not going to be negative 3x plus 1. It's going to be negative parentheses 3x plus 1. So that's minus 3x minus 1. Okay, so now we're going to bring that 3x over here. So that'll give us xy plus 3x equals negative 1. And what do? All right, we're trying to get the x by itself. We're going to factor out that x and divide on both sides by y plus 3. X is negative 1 over y plus 3. Swap the x and y's to get our inverse function. Y equals negative 1 over x plus 3. Okay. Problem 20. Let's see here. Start out 2x minus 3 over x plus 4. So let's write it as y equals. All right. So let's see here. So I'm going to get the x by itself. So I'm going to start out by multiplying on both sides by x plus 4. All right. Same issue here. We need to get this x and this x together. So to do that, I'm going to distribute this y into the parentheses. Xy plus 4y equals 2x minus 3. All right, let's see. I'll bring this over to this side. So I'm going to subtract xy on both sides, and then I'll add 3 on both sides. So what do we come out of this with? 4y plus 3 equals 2x minus xy. And then again, the trick here is to factor out the x. And then divide on both sides by 2 minus y, and there we go. 4y plus 3 over 2 minus y. Swap the x and y's, and we get 4x plus 3 over 2 minus x, and there's our inverse function. Okay, let's look at problem 22. F of x is negative 3x plus 4 over x minus 2. All right. So first let's write it as y equals and now again we want to clear that denominator. So we'll multiply on both sides by x minus 2. So those cancel out. And this will be negative 3x minus 4. Again, that negative sign gets distributed, right? Anytime that it's out in front of a fraction like this, that means it's either going to get distributed to the top or the bottom. That's up to you, okay? But it has to get distributed. All right, so now I'm going to distribute the y. And this will be xy minus 2y equals negative 3x minus 4. So, let's move the 3x over here, move the 2y over here. All right, so those cancel out, and what are we left with? xy plus 3x equals 2y minus 4. Okay. So again, over here, we're working to get that x by itself. X times y minus 3. And then divide on both sides by y minus 3. And then swap the x and y's. Y equals 2x minus 4 over x minus 3. And that is the inverse function. Okay. So, that's it for those problems. Let's look at one of these applications. Problem 24. The speed of a vehicle in miles per hour that leaves skid marks d feet long is modeled by the equation r on d is 2 times the square root of 5d. Find d of r, the function that tells you the stopping distance for a vehicle traveling r miles per hour. Okay. So this is something that they do in crash investigations for law enforcement or in industry. You measure the distance of the skid marks, and that can tell you, within reason, how fast the car was going. You need to know the effect that the brakes for a particular model of car have. And then if you do know that, then you can calculate the speed the car was going. So let's replace this just with an r. Okay, and so let's see. To start out with, let's divide on both sides by 2. R over 2 square root 5d. Then we'll square both sides. This will be r squared over 4 equals 5d. And then I'll multiply by 1/5 since I've already got a denominator over here. Those 5's cancel. There's our d. and then our function is r squared over 20. And remember, if it's an application, we usually don't have to swap the independent and dependent variables. We typically do that if we're working with x's and y's. Okay, so that's it for inverse functions, and that covers most of chapter 1. The only thing left now is those applications in section 1.9. That'll be the next video. As always, if you have any questions about this, please let me know. Thanks.